Alright, so let's go ahead and solve this first order differential equation. Now, first thing I'm going to do is I'm going to multiply, so rewrite this right as dy equals y e to the minus t dt. Okay, and I'm going to bring this y onto the left. We get 1 over y dy equals e to the minus t dt. All right, so now we have all the like terms on the two separate sides of the equation, right? So this allows us to take the antiderivative of the integral of both sides. Okay. Now, okay, so this is fairly straightforward, right? This integral. This is just the natural log of the absolute value of y. Okay. Okay. And this is going to take a bit more work, right? So let's just say, so we need to find the integral of e to the minus t dt. Okay, so let's see if we can work this out using substitution, right? Because that's the easiest thing to do. So my approach is always to just try that first, right? So if we and that seems promising, because if we see that if we differentiate this, we get a constant term with respect to t, and there's no other t outside, so it looks like we can substitute that in. So if you say let u equals minus t, then du by dt is minus 1, right? And du equals minus dt, or and then taking the form that we need, it's just minus du equals dt. Okay, so now we have all the things we can substitute this in, right? So that gives us the integral of e, so plugging this in, e to the u, and then plugging in minus du for dt is minus du. So we're just going to take this minus sign outside, and then the integral of e to the u is e to the u, so it's just e minus e to the u plus c. And this should be plus, oops, this should be plus c. Okay. All right. So now we can, well, okay, and also we also want to replace this with the t value back in. So this is equal to minus e to the minus t plus c. All right. Now bringing both of these back together, this term and this term, we get the natural log of the absolute value of y plus c equals minus e to the minus t plus c. Okay. All right. So now we can recognize that we have two c terms. We can just get rid of one of these, because the sum of two arbitrary constants is just another arbitrary constant. Right. Let's just erase that. Okay. And we can take, I'm just going to move this up here, and then we'll move this up here so we can have the natural log of the absolute value of y equals minus e to the minus t plus c. Now, we're trying to solve for this y, okay? So we can take the exponent of both sides, so that will give us the absolute value of y equals e to the minus e to the minus t plus c, okay? And we can separate these plus signs out, so we can say the absolute value of y is e to the minus e to the minus t times e to the c, okay? So if you have a to the b plus c, this is the same as a to the b times a to the c. Okay, so that's just an aside. All right, so now we're still trying to solve for this y term, for this y value, right? Okay, and we can rewrite this as y equals some value d times e to the minus e to the minus t. So I've essentially incorporated this absolute value function into this constant, into this term, and I've gone over this a couple of times in other videos. So just check out any of the other absolute value problems within the title, and it'll tell you, and I'll explain why. So I'm not going to spend time on that here. Okay, so this looks a little confusing, so I'm just going to draw a line. So this is just, so there's something else and there's something else. Okay, right. So this is what we have. Okay, now we are given that at y of 0, so this is basic. So this can be written as, this is basically y of t, right? Because it's in terms of t, is d e to the minus e to the minus t. Okay, and we're given that y of 0 is 1. So y of 0 is 1. Okay, so if we substitute 0 where t is, we get 1 equals d times e to the minus e to the 0. Okay, and a to the power of 0 is 1. Okay, so this will be 1 equals d e to the minus 1, which is 1 equals d over e. Therefore d equals e, right? So that's, and then you can take this value, and then to complete the equation you can say, so this is the answer, and this is also an answer, but we can plug this d value back in, so we can say y equals e times e to the power of minus e times t. Okay, so this is e to the power of 1 times e, so we can rewrite this as e to the power of minus e to the power of minus t plus 1. Okay, and that's the solution.